So in this video we are going to discuss about Modulo 6 asynchronous counter. It is also called as Ripple counter. Modulo 6 Ripple counter. So since it is Modulo 6, it ranges from we already know the state diagram which I have discussed in the previous video. So you have 0 0 2 0 0 1, and from 0 0 1 it goes to 0 1 0, followed by 0 1 1, followed by 1 0 0, 3 5 and 6 1 0 1. Okay, so after that it will goes to 000. So for this one it is nothing but QA QB QC, right? The value of QA QB QC, that is this is this is QA QB and QC. So here QA is nothing but your MSB and QC is nothing but your LSB. Okay, so for designing this one you require a 3 JK flip-flops, okay, which is QA, QB and QC. You have to write the MSB here and the LSB here. Okay, so since it is up counter, you can see it goes from 0 to 1 1 to 2. So you have to connect this Q bar to the rising edge of the next state. Since it is asynchronous counter, I have to connect the output of the flip-flop is connected to the next flip-flop clock input. Okay, and you know that you have to give the inputs, that is JK to 1 1. Okay, always the JK value should be 1 1. Why? Because you know the functionality table of JK flip-flop, where JK and Q plus, when it is 0 0 0 1 1 0 and 1 1, what happens? It is Q 0 1 and Q bar. So whenever 1 1 JK is 1 1, if Q value is 0 is your present state, then if I give 1 1, JK is equal to 1 1, the next state is 1. So this is your next state. Okay, when Q is 1 at the present state and JK is equal to 1 means Q of next state is 0. Okay, so it will alternate. If it will toggle when JK is given as 1 based on the value of clock. Okay, only when the clock is active. Okay, so you can see for the QC, let me explain the QC. So here if I am giving a rising edge of the clock, okay, so if I give the clock pulse and if I give the input J and K is equal to 1, initial value of let me assume the initial value of QC is 0. So initially it is 0. Okay, initially all the flip-flops are 0 value. Okay, so if I give, the moment I give JK is equal to 1 and the clock is also present, what happen? The next state it will goes to 1. So it will goes to 1. Okay, so again I'm giving the clock and JK value is equal to 1 1. So now the Q value is QC value is 1. After giving the input and the clock, it again goes to 0. So this cycle will repeat, right? So this cycle will get repeated, okay. So you can see this is your rising edge of the clock. This is a rising edge of the clock. This is called as rising edge, and this is called as falling edge. Okay, so if QC value, if this is rising edge, means for Q bar this is your falling edge. Okay, for Q bar this is your falling edge, and for Q bar this is your rising edge. Okay, so the rising edge is given to the next stage of the JB KB flip flops. Okay, so whenever JK is always 1, so whenever the rising edges come, okay, so whenever the rising edge comes, so initially the QB value is 0, QB value is 0, so whenever the rising edge comes, because it is not Q, it is not Q, it is Q bar, so this is your rising edge. Whenever the rising edge comes, it will changes its state, right? So till this one, so here again the rising edge comes, so it will toggle to 0. Again here the rising edge is coming, so it goes to 1. So again the rising edge comes, so it goes to 0. Again the rising edge comes, so it goes to 1. Okay, so QB bar means this is your rising edge and this is your falling edge. So this is your rising edge for QB. So QB is given to the A flip flop, right? So initially the QA value is 0 till the rising edge comes, right? So whenever the rising edge comes, it is a falling edge of QB and rising edge of QB bar. So QB bar only we are giving. So this is your rising edge for this flip flop. So it will toggle to 1. Okay, till the next rising edge comes. Okay, so now you see, if you see the value, initially it is 0 0 0. Okay, next it is 0 0 1, next 0 1 0, next 0 1 1, this is 1, this is 0. Okay, 1 0 0, 1 0 1, 1 1 0, 1 1 1. Okay, so next what I need to find, whenever 1 0 1 comes, it will again goes to 000. Okay, so I have to connect whenever it will reach, so it should not reach the next state. The next state should be 1 1 1 0, right? So the next state should be 1 1 1 0. So this state should not be reached, that is QA, QB, QC. Okay, so you take QA, so you take QA, where is QA? This is your QA, and you take QB. Okay, so give it to an AND gate. So why I am taking only QA QB means because for QA QB the value is 1 1. Okay, so give it to a NAND gate and you connect it to the reset pin. Okay, so this is your reset pin. Okay, reset pin of the flip flops. So whenever it is 1, it goes to 1 1. This is 0. So 0 is given to a active low pulse. So if it is active low pulse, the reset get turned on. So all the flip flop goes to initial state, that is 0 0 0. Okay. So whenever it tries to reach the 1 1 0, so 1 1 0, it goes to the so it goes to 0. Okay, so it will not reach 110. Okay, since if it reach 110, it goes to this AND gate and it goes to the reset and it makes the next state value to 0 0. Okay, so you can see you can give from Q bar to the rising edge of the clock, or from Q to the next state next stage from Q, if you give to the falling edge of the flip flops. Okay, if you give Q to the falling edge of the if you give Q to the falling edge of the Q as an input to the falling edge of the next stage flip flop, means then also it will work as a up counter. Okay, so you can connect it like this also, or you can connect it in this manner also. Okay, that is from here to the falling edge of the next stage flip flop. Okay, so vice versa, it will work as a down counter.